Take a moment to pause your screen and try this short warm-up. Describe the order of the steps you would follow to evaluate the expression. All right, so remember when you are evaluating expressions, we follow the same order around the world. We start with parentheses, then we do exponents, then we multiply and divide. Remember that's one step and you go left to right. And then finally we add and subtract left to right. So as we look at this problem, we look for the parentheses first. And there is something we can do in the parentheses, but there's actually two things to do in the parentheses. So we still follow PEMDAS within the parentheses. So if we're deciding between subtraction or division, we see that subtraction is in the last step, division would be in the step in front of it. So we want to go ahead and divide first, in which case we'd get 4 minus 3, since 9 divided by 3 is 3 in the parentheses. Everything else stays the same. Then we finish off the parentheses by subtracting 4 minus 3, and that'll leave us with 5 squared plus 2 times 1. That's the parentheses step. Next, we look for any exponents, and we see that there are exponents at the beginning, or there at least is one set of exponents, 5 squared. Remember, that's not 5 times 2. It means that we're multiplying the 5 by itself. So 5 times 5 is 25, plus 2 times 1. Exponent step is complete. Next, we look for any multiplications or divisions, and we read it from left to right. There is a multiplication at the end, 2 times 1, which is just 2. That leaves us with 25 plus 2, which is 27. So the order that we followed was inside the parentheses. We did division first, then subtraction, because those were in the parentheses. Next, we did the exponent, then the multiplication, and last, the addition. To start with, I'd like to do a think and share. So on your own, if you're watching this video, I'd like you to think about inverse operations. What are inverse operations? So if you didn't get enough time, go ahead and pause before you listen to the next part. What are inverse operations? Well, inverses sometimes are called opposite operations. Okay, operations that undo each other, like addition and subtraction, or multiplication and division. So if you think about it, let's take a number like 10. If I add 3, how would I undo adding 3? I would subtract 3. 10 plus 3 is 13, and 13 minus 3 is 10. So whatever operation you do to the 10, you can undo that with an inverse. If I divide it by 2 and then multiply it by 2, I'll still get 10. 10 divided by 2 is 5. 5 times 2 is 10. So multiplication and division will also undo each other. In a two-step equation, which operation do you undo first? So a two-step equation might look like this. 2x minus 5 equals 7. And in that equation, there are two different operations to undo. There's the multiplication between the 2 and the x, and there's the subtraction. So when we are trying to decide which one to undo first, we actually follow SADMAP, which is PEMDAS written backwards. So we start with undoing any addition or subtractions. Remember, that's the same step. Then we undo any divisions or multiplications. Again, that's the same step, the second step. Then we undo any exponents. And last should be whatever's inside the parentheses. So let's look at some examples. Here's an equation, x plus 8 equals 19. When you're solving an equation like this, it can be helpful to draw a line, or what I call train tracks, around the equal sign. This gives you a visual representation of the two sides of an equation, which represent a balance. Identify where the variable is in relationship to the train tracks. In this case, the variable is on the left-hand side, x plus 8. Our goal is to try to get x completely by itself. So we have to get rid of the plus 8 in this problem. So think about what is the inverse of adding 8, or how do we undo adding 8? Well, we would take away or subtract 8. Now, the fundamental rule of algebra says I have to do the same thing to both sides of the equation to keep it balanced. So I subtract 8 on each side, and if I take the positive 8 and subtract 8, it gives me 0. X plus 8 minus 8 is just x. On the other side, 19 subtract 8 is 11. So x equals 11 is my solution. Now we can always check this by substituting in the value of the variable to our equation. We started with x plus 8 equals 19. Let's replace the x with the number 11 and check to see if that's true. Is 11 plus 8 equal to 19? Well, yeah, 11 plus 8 is 19, and 19 equals 19. Just confirms that x equals 11 is our solution. So in this example, there was really only one thing to do. We had to subtract 8 from both sides. That makes it a one-step equation. In our second problem today, 4a plus 3 equals 11, I see that there are two operations. There's the multiplication between 4 and a. Remember, that's 4 times a. And there's also the addition, the plus 3. So think about following the reverse order of operations, which we can remember using SADMAP to help us with the order of how to solve. We want to start by undoing any subtractions or additions. Well, I see that there's a plus 3 in this problem, so let's start by taking away 3 to undo it. 3 minus 3 is 0. But I still have that 4a on the left-hand side. And 11 minus 3 is 8. Now we have to get rid of the multiplication, so we divide to undo multiplication. Divide by 4 on each side, and our final answer, when we take 4 divided by 4 to get 1, or 1a, and on the right-hand side, 8 divided by 4 is 2. A equals 2. We can always mentally check our answer. If I replace the a with the number 2, I should get 11 based on my equation. So 4 times 2 is 8, and 8 plus 3 is 11. Our answer checks out. In our third example, we have 8 equals 3r minus 1. You might notice this time that the variable is on the right-hand side, and that's okay. We still solve the problem the same way. We still use inverse operations, and we work backwards using SADMAP. So we start by looking for any additions or subtractions that we can undo. And I see that we can undo the minus 1 as long as we add 1 on both sides. Well, 8 plus 1 is 9. The negative 1 plus 1 is 0. And I still have the 3r. Remember that 3r is the same as 3 times r. So we want to undo multiplication by dividing. 3 divided by 3 is 1. 9 divided by 3 is 3. R equals 3 is our solution. Then again, you can always check your answer by plugging in 3 in the place of r in the equation. 3 times 3 is 9, and 9 minus 1 is 8. In our fourth example, we have 9 minus c equals negative 13. I start by drawing my train tracks. I notice that the variable I'm trying to solve for is on the left-hand side, in which case I want to try to get rid of the 9 first. Now this problem can be a little tricky because the temptation might be to see the subtraction and want to add 9 to both sides, like this. However, when you do that, what's 9 plus 9? Well, that's 18. which if we do this, it's going to give us 18 minus c equals -4. And that doesn't help us try to get c by itself at all. So think of it more as what can I do to that 9, which was a positive 9, to make it go away, to make it turn into a 0. So we actually have to take away 9 on a problem like this to get the 9 to cancel out. 9 minus 9 is 0, but be careful, what's left over is negative c equals -22. Then we have to remember that when a negative sign is in front of a variable, that's the same as saying -1 times that variable. So if we want to undo -1 times c, we're going to divide by -1 on both sides. A negative divided by a negative is a positive, so that's going to leave us with positive c. And on the other side, again, a negative divided by a negative is a positive. That leaves us with positive 22 as our solution. If you check your answer, put 22 in the place of c. 9 minus 22 equals -13. That is true. So 22 is our correct answer. I'd like you to pause the video and try number 5 on your own. All right, let's check and see how we did. Remembering to follow SADMAP when solving equations, we want to start by looking for any subtractions or additions that can be undone. We see that there's a +4 in this equation, so let's start by subtracting 4 on each side. 4 minus 4 is 0, so that's going to leave us with x over 6 equals 15 minus 4, which is 11. Now it may look like it's a fraction, and you might be wondering, well, how do I get rid of a fraction? But remember that the fraction is really just a division. So if I want to undo divided by 6, I can actually multiply by 6 on both sides. And on the left-hand side, we take 6 times x over 6. It's going to look like this, which we know is just x. And then 11 times 6 is 66. X equals 66 is our solution. If we plug that in to check, 66 divided by 6 is 11, and 11 plus 4 is 15. So 66 is the correct answer.